Hi everybody, sumchief here. Got a function today which is undefined at x equals -1. And you can see that the cubic polynomial in the top, x squared plus 2x squared minus 5x minus 6, is divided by x plus 1. So we're going to go ahead, plug in x equals -1 into the function, see what happens. So -1 cubed plus 2 times -1 squared minus 5 times -1 minus 6, and then -1 plus 1 in the denominator. So we've got -1 plus 2 plus 5 minus 6 divided by 0 gives us 0 over 0. So this is a bit of a problem. 0 in the numerator, not a problem. 0 in the denominator, this is a bit of a problem. So the function here is undefined. So we proved that the function f of x is discontinuous at x equals -1. So let's have a look into it and see what we can do to find a solution. So what we can do is got two popular methods: a Hopital's rule, or there's always the Squeeze Theorem. Two popular methods, but we can see that there's a chance we could factor the numerator to avoid this undetermined form. So x plus 1, which is in our denominator, if we can take that out somehow of the numerator, maybe we can get a bit of factoring, find a solution. Okay, so now we're going to try and factor out the x plus 1 out of our cubic polynomial in the numerator, x cubed plus 2x squared minus 5x minus 6. So what we do know is, if the cubic has got x cubed and we need to multiply by the x that we're factoring out, we're going to get left with x squared in the quadratic. So therefore that will take care of our first term. So our first term, that when we factor out x plus 1 from the cubic, will be a quadratic with x squared as its first term. And all quadratics have x squared as one of their terms. So that's a great start. So now we've got -6. So what we need now is a number that when we multiply it with +1, we end up with -6. And there's only one number that will do that, and that's -6 itself. So therefore we've got two of the terms of the quadratic already taken care of. We've got an x squared and we've got a -6. So now what we see is we've got 2x squared here in the cubic, and we're trying to factor out an x plus 1. And what we do know is we've got an x squared which is going to be taken out of it. So we've got an x squared which will multiply by a plus 1. So when they get cross multiplied, you'll get a plus x squared, and then we get an x which will multiply by another value which will always be an x value to get up with an x squared. So x times another x, for example 2x, will give us 2x squared. So that's always going to give us our x squared term. So next what we need to find is a plus x squared with another x multiplied by x to give us 2x squared. And the only value we can possibly plug in for that is a single x. So therefore, when we factor out the cubic polynomial, x cubed plus 2x squared minus 5x minus 6 is going to be x plus 1 times x squared plus x minus 6. Now this looks a lot more promising, because now we can just plug in our values and see what happens. So rewriting the function, so we've now written it: x plus 1 times x squared plus x minus 6 divided by x plus 1. We've not changed the value of our function here at all. All we've just done is written it to try and suit ourselves, to try and find a solution. So now we've got an x plus 1 in the numerator, x plus 1 in the denominator, and we can see we can cross cancel these out, and that just leaves us now with f of x equals x squared plus x minus 6. So now what we've got to do now is just plug in x equals -1 into our function x squared plus x minus 6. So what we get is f of -1 equals -1 squared plus -1 minus 6, which gives us -6, and that's the solution to our question. So when f of x is at x equals -1, the answer is -6. So I'll bring it here: f of minus 1 of our function equals minus 6. So I've drawn a little graph here as well so you can see what's happening. When x equals minus 1, y is minus 6. And that's our solution. So leave any comments below. The solution for any question you want to see the answer to, just put in the comment box and I'll see what I can do. And as always, please remember to subscribe. Thanks very much.